GATE 2020 Physical Metallurgy. The dielectric material is the two coupled electric conductor, metallic magnet, two coupled electrical conductor, and electrical insulator. The dielectric material is an electrical insulator. Okay. The angle between two neighboring tetrahedral bonds in a silicon having diamond cubic is. So if you see the diamond cubic structure will be like this. So the angle between two neighboring atoms is nearly 109.5 degrees. The sequence of precipitation during aging of aluminum, a 4 weight percentage copper alloy is. So if you'll see first, the Ionapester zones will be precipitated first, and then they are more coherent inside the matrix. So they will be precipitated first, and then they lose their coherency to become semi-coherent, and then they lose their complete semi-coherency also to become incoherent, and then finally we get theta precipitates. So it is GP to theta double dash to theta dash and theta. These are the zones. The number of atoms per unit area in 100 plane of lead is dash nanometer per nanometer square. Given the crystal and the atomic radius of lead and FCC are 1.175 nanometers respectively. Okay. So crystal structure is FCC and lead has an atomic radius of 0.1. So number of atoms per unit area is given by number of atoms in 100 plane by area of the 100 plane. So if you will consider FCC crystal structure, let's take this as 100. Okay, sorry. This as 100 plane. This is X direction, Y direction, and Z direction. This is 100. So the area of that plane is A square. The number of atoms in that plane of FCC is 0, 0, 2 atoms. And here 2 atoms will be touching each other. So in a FCC crystal, the root 2a is equal to 4r. In FCC crystal structure, along the phase diagonal, the atoms will be touching each other. So root 2a, so a is equal to 2 root 2 r. So substituting these values here, 2 into root 2 into r value is 0.175. Leave it in nanometers itself. So you get, if you calculate this, you'll get nearly 8. So answer is 8. So in an X-ray diffraction pattern, X-ray diffraction, you get from an elemental metal of FCC structure shows the first peak of Bragg at a Bragg's angle of theta is equal to 24.65. The lattice parameter we need to calculate. Lambda is given as 0.1543. We know according to Bragg's law, n lambda equal to 2d sine theta. So first peak in FCC is 111 plane. So d is equal to a by root 1 square plus 1 square plus 1 square. As we know, d is equal to a by root over h square plus k square plus l square. So here we know lambda already 0.1543 and 2 into a we need to calculate by root 3 into sine of 24.65. So calculating this we get a is equal to 0.32 nanometers. This is the answer. So The gray iron, ductile iron, zirconium alloy, and beryllium copper alloy. Which of the following materials has the common applications? If you'll see, the gray iron, cladding of uranium fuel in a nuclear reactor, base structure for heavy machineries, and so the gray iron is used for base structure as it is used in mostly damped applications. It can absorb a lot of the vibrations, etc. So it will be used as damping applications of heavy machineries. And then the ductile iron will be used in valves and body pump bodies. And the zirconium alloy is used as a cladding for uranium fuel and nuclear reactor. Beryllium and copper are generally used for the jet aircraft landing gear bearings. So you might have heard about the tin, brass bearings, etc. So 2314. The magnesium tin phase diagram exhibit two eutectics on either side of the high melting intermetallic line compound. And magnesium 2SN at 561 degrees centigrade. Length is 36.9 weight percentage of tin and alpha is 14.48 weight percentage of tin and Mg2SN 203 97.87 tin and beta tin almost 100 weight percentage of Mg2. After the eutectic reaction, After the eutectic reaction has gone to completion, an equilibrium has been attained at a temperature just below 561 degrees centigrade. The amount of the eutectic constituent present in the alloy of magnesium 50 weight percentage tin is approximately. Okay, so it's given as at equilibrium composition of Mg2SN is equal to the tin weight is given as 118. So we are writing in tin weight percentages into 2 into 24.3 plus 118.7, which is equal to 70.95. This is the equilibrium, the compound tin percentage, in weight percentage of tin. Now you need to apply the at a eutectic. The eutectic reaction is given as liquid gives rise to alpha plus Mg2SN and almost so 70.95 and 14.48, 36.9. The liquid is at this composition alpha and you get Mg2SN. So you need to find the amount of eutectic constituent at 50 weight percentage of tin. So this is 50. Liquid gives eutectic. So for finding out eutectic, you apply river rule on this side of the. So eutectic constituent equal to 70.95 minus 55. 70.95 minus 36.9 into 100. So F of eutectic is equal to 0.62. So it is nearly 62 weight percentage of tin. I think most of the coaching institutes hasn't taught this. Determine the correctness or otherwise the following assertion and the reasoning. The rate of homogenization The rate of homogenization in a dilute substitutional solid solution of B in A is controlled by the diffusivity of B. Atomic migration cannot occur along dislocation and grain boundaries. See here, atomic migrations happen along the dislocation and also along the grain boundaries. So the reasoning itself is wrong. And the rate of homogenization in a dilute substitutional solution of B in A is controlled by diffusivity of B. No, it also depends on the diffusivity of A. So this is also a wrong option. So both are false. So if you'll see the options, you need to see the column one under electronic behavior, copper, iron, mercury, silicon, ferromagnetic, superconducting, semiconducting, and diamagnetic. Copper is diamagnetic. It has an unpaired electron, so it becomes diamagnetic. Iron is ferromagnetic, we all know. And mercury is the superconducting, and silicon is semiconductor. Silicon, most of the semiconductor industries use silicon. And answer is 4123. The radius of largest interstitial atom, still atom that can be accommodated in an octahedral void in BCC iron without distorting the lattice is. Assume hard sphere model and radius of the iron atom as 0.124. So the octahedral void of BCC. In an octahedral void, R by R is 0.155 for a BCC. So and it is 0.124 into 0.155. This is nearly equal to 0.56. In a liquid, copper is cooled to 1353 Kelvin. 1353 Kelvin. Magnitude of the driving force of liquid to transform to solid is dash joule per mole. Given the melting temperature and enthalpy of the melting point are 1356 and 13 kilojoule per mole. So, the driving force for the transformation GV is equal to delta HM into 1 minus T by Tm. So here it is given as melting, the enthalpy of melting. If it is given fusion, you'll write a negative value. So it is fusion or negative, both will have negative value only, into 1 minus T is given as 1353 by 1356. So you'll get minus 13.3 into 10 power 3 into 3 by 1356. And you get the value as but here you should see the magnitude of the driving force is asked. So it will be delta GV is equal to 28.8 joule per mole. Okay. The zone refining of silicon results in the residual phosphorus of nearly 0.1 parts per billion. So you should remember this as 0.1 by 10 power 9. If it is ppm, it is 0.1 by 10 power 6. As it is ppb, it is per weight. Okay. The electrical conductivity of this zone refined silicon is dash ohm per meter. Okay. Avogadro number is given, density is given, atomic weight is given, charge of an electron is given, mobility. The mobility, you need to calculate electrical conductivity. Electrical conductivity is given as n into number of electrons into its mobility into its weight, as this is given in the n value will be per weight. So it will be into weight. Now, to calculate weight or n by v, we know density is equal to nm by ni into volume, where this is number of atoms and the molecular weight. So it is N by V is equal to rho Na by M, which is equal to 2.3. You can convert this into kg. So 2330 into 6 into 10 power 23 by, as it is in grams, 30.97 into 10 power minus 3. So total will be coming to 4.53 into 10 power 28. So the electrical conductivity is given as 4.53 into 10 power 28 into 1.6 into 10 power minus 19 into the mobility is given as zero point 0.2 into the weight is given as zero point 0.1 by 10 power 9 into by 10 power 9. I mean, so it is nearly 10 power minus 29 and 4.53 into 1.6 into zero point 0.2 into zero point 0.1, 2 by 100 is nearly uh, 14 into 0.01. So it is 0.14.